You can see that it starts from the left and moves to the right, then it moves to the extreme right, then again moves to the left. Now let me show you the code. So see that this is our initial state, the leftmost LED is on, then we do the bit shifting to the right by 1 and it reaches the nextmost LED. See, this one is now at this point. Now after another command is executed, one bit shift to the right further, then this reaches this point at this LED is on now. Now again further bit shifting makes a reach to the pin number B0 LED. Then now again we do the left shifting. At this time we were doing the right shifting and now we do the left shifting. Now the bit moves here. Now after further command is executed of the left shifting, it moves here. Then it again comes back to the initial state. So this is our initial state as well. See, so that's what is happening over here. Simple as that. See that this is the bit shifting taking place. It goes to the right and then comes back to the left step by step. Hello guys, welcome to learning microcontrollers. In this video, I will show you how you can use the bit shifting operators in MikroC. There are two operators, one to shift right and one to shift left. Double greater than is to shift right and double less than is to shift left. That's all. And I will give you a hardware demo using 4 LEDs. We will simply move the LEDs to the right one by one, then we will move it to the left, like they will be like a dancing LED mini project for the demonstration purpose. So first of all, let's set up our hardware before we move on to the programming. So guys, this is our PIC16FA77A microcontroller having 40 pins. It's a DIP version. I'm gonna use for demonstration purpose. And guys, these are the 4 LEDs. Now let's first of all connect them. So guys, as you can see, each LED has 2 pins. One is longer, one is shorter. Longer is always the power and shorter is always the ground. Now guys, to connect them with a PIC, you will need a resistor. This safety resistor can be of any value from 100 to 500 ohm. If you go greater than 500, it's fine, but that will dim your LEDs. Higher the resistor, lower will be the brightness of the LED. So 220 ohm is an ideal value. I always use 220, so you can use the same too. Now guys, let's connect the LED. Now we start from the bottommost LED. Let's connect the power pin, that is a longer pin of the LED, with one end of the 220 ohm resistor like this. From the other end, you can connect it to any available digital input output pin of a single port. We need a port now. Remember that these 4 LEDs must be connected to a same port for this type of project. So I connected to the pin number B0. Now the second LED, similarly through a resistor, I connected to the B1. Third LED again through a resistor I connected to the pin number B2, and the fourth LED, the topmost, again through a resistor I connected to the B3. Now see that these LEDs are at the same port B0, B1, B2 and B3. Now this will be easy to demonstrate using bit shifting. We will shift our bit in such a way that whenever this LED blinks, then we will shift a bit, this LED will turn on. After that this will turn on, this will turn on, then they will go back, this will turn off, this will turn on, this will turn on, this will turn on. That's how we are going to use our bit shifting here. Now for the ground pin, just comment them and send it to the common ground of the PIC like this. In this way our hardware is completed. So what we're going to do here is simple as that. For demonstration purpose, I will give port B a certain value which will turn on this LED first. We will blink this LED. Then what we are going to do is that we will start from B0, this LED. So whenever a bit, we will use a bit shift operator to the right, the LED will start moving one by one to the right like this, and we will give certain delay like 250 milliseconds, one by one, and then it will come back one by one. That's all what I'm going to do here. So let's get to the hardware before we move on to the programming. So guys, this is our hardware over here. As you can see, we have only 4 LEDs will be used, 1, 2, 3 and 4. Leave one in the center and they are total like 4 LEDs. And this is our PIC16FA77A, and behind it is the PIC3. I have a video on this, how to set up your hardware. I will also share the link of that video in the description of this video as well. So guys, let's move to the MikroC for PIC to start with the programming. So guys, this is our MikroC for PIC. Let me zoom in so you guys can see better. As you can see, it is version 7.2.0. You can use a higher version as well. Higher is always better. Click on File, New project. Now guys, this is new project wizard. Click on next. Write the name of the project. Bitwise tutorial by learning microcontrollers, like this. Now guys, this is the path. This is the microcontroller. Select the one you are going to use. I'm going to use a PIC16FA77A. and the crystal at pin 13 and 14 of my microcontroller is 20 megahertz. So I will write 20 here. Now click on next and finish. Now guys, this window pops up. Before you do anything else, first of all, save your work, press Ctrl S like this. Now guys, first of all, we initialize the port, that is stress B dot, complete port B equals to 0 cross 0 0. Now the port B is an output port, this is the direction register, 0 means it's output and 1 means it's an input. Now guys, give the initial state, port B equals to, now initially we want all the LEDs to be off. So there are 8 pins, so 1, 2, 3, 4, 5, 6, 7, 8. Like this, I am giving in bit sequence. You can also give it in the integer. You can use that converter at the bottom, just write 0, 0, 0. 0 here, when you write 2, it auto converts to the 8 bit. And if you have a better 16 bit microcontroller, just make it 16. So I will use this quick converter if I want to convert it to integers. See that? So we will be using the binary directly, that's better. So there must be like 8, 1, 2, 3, 4, 5, 6, 7, 8. Because there are 8 pins at port B. See that? We have total of 8 pins from B0 to B7. So we are giving port B 8 bits. So 1 bit represents 1 pin. So we have LEDs only at 4 pins, that is the first 4. Starting from the right to left, this is B0, this is B1, this is B2, this is B3 and up to B7. From right to left, it's B0 to B7. I also write it from right to left, it's B0 to B7 like this. Now guys, initially all the pins are off, all the LEDs are off. Now we give some initialization delay. This is not necessary, but I always suggest you give it in the one time loop. Now we move on to our forever loop. I write while 1. So we start from one LED, whatever the LED we decide, okay, we turn on one LED here. Now which LED we should turn on? We have LEDs at these 4 pins. So we start from this LED. That is the leftmost LED like this. So let's build and burn it and see which LED turns on. So I build it, I go to the Pickett programmer tool, click on file, import hex file. This is the file we just created, click on write. Okay, let it build and see does this bit sequence work. Now according to this, only the pin B4 LED at B0, B1, B2, B3 at B3 should turn on and should remain on. So we go to the hardware, let the code burn. Okay, let's power it up from the pick. See, it's on. So that's perfect. So this is the leftmost, that is the B3. This is our B3. This is B2. This is B1. This one. And this is B0. Now what we do is that we will use the bit shifting. We will move this bit here, 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 and then all the way over here. So we will do bit shifting to the right and then to the left. So for that we write the code. So first of all, I write here is that port B again equals to port B, and this means we need to shift the bit to the right by 1. If I write 2, it will shift the bit right by 2. So this bit will come here once this command is executed. So first of all, we need to keep this on, like this should remain on for like how much is good, 250 millisecond is good, and then after that the bit will be shifted by 1 to the right. Now we are at here, we still have 2 points more to go. So we take this twice, this command twice, copy it, paste it twice like this. Now see that this command is here, now the bit is here. Once this command is executed, our bit will be here. Once this is executed, bit will be here. Once this is executed, bit will be here all the way to the end. I also write it if you want later on, for you it will be helpful. So at this point the bit will be shifted by 1 to the right like this, and now at the next step the bit will be shifted further left to the right by 1 because we have given 1 here. If you give more than 1, that digit like 3, it will be shifted to the right by 3. See, and now at this point, after this command is executed, it will be at the last LED like this. See that now this is the one way. Now we bring it back, we do the shifting to the left. Copy this again and paste it here, paste it one more time because we have 4 steps like this. Now we are at this point over here. what we do is that we change the direction. Now again the bit is going back. Now at this point, bit is again at this point. See, now the bit is shifted to the left by 1. Now again, just make it left. Now bit is being shifted to the left. Now it's at this point. That is the third LED is on, like this. Now again, we shift the bit to the left further. Now the bit is at this point. That's 1, that's 2, 0, 1, 2 and 3 at this point. So we do not need the fourth one because we don't have LED further. So that's it. Now see, we go through the code again. Now see, this is our initial state that we gave here. That is only the fourth LED is on as shown in the hardware. Now as soon as the bit shifting starts, we shift the bit to the right by 1. So it will come at this point. Now this LED is on. Now after further shifting, this LED is on. After further shifting, this LED is on. Now again we go back. We go the other direction. Now this LED is on. Now we go the other direction. This LED is on. Now other direction. Now this LED is on. So this means that we have just came back. Now I built this code. Okay, let me build it. It's built. Let's zoom out. I click on write. Okay, the new code is being written. Let's get to the hardware. Let's wait for the code to write up. Okay, see that the bit shifting first of all takes from left to right, then right to left. See that? Simple as that. So guys, that's how you can play with the bits in MikroC for Pig. You can use the bit shift operators to shift the bits either to the left or to the right. This technique is very useful, especially whenever you are receiving data from a single input pin, single digital serial input pin like DHT22 sensor or DHT11 sensor. Then you need to do this bit shifting because you will get a bit one by one. So you have to store it in a single variable. So this is a very useful technique. You will find a lot of uses of it in your programming. So guys, I hope you learned something from this video. If you have any problems, you can still ask me in the comments. So thank you very much for your time and patience, guys, and have a nice day. We'll see you in the next video.